Okay, so now the next question is, how do I make this point plotting a little quicker, right? It's pretty labor intensive. It's a method that works all the time in graphing, and we're looking for, potentially faster way to get a graph. And so one of the first ways that we can do that is by looking at some very special points. So let's talk about what they are, and then we'll show you how that's going to help you with your point plotting. So for starters, one of our special points is known as an x-intercept. A visual definition is it's a point or location where my graph is crossing the x-axis. So I've got three graphs here. I've got a line graph, I've got a parabolic graph, and I've got a circle. So all the x-intercepts are at the locations where my graph is crossing the x-axis. So there would be an x-intercept right there. Right? That's a location where we're crossing the x-axis. This parabola actually has two x-intercepts, right? Because there's two locations where we're crossing the x-axis. And the circle also has two x-intercepts because we're talking about two locations where we're crossing the x-axis. And stressing the idea that it's a point, right? The location where we're crossing the x-axis, well, it looks like we're sitting at -3, 0. All right, so -3, 0 is the location, the point, where we're crossing the x-axis, x-intercept. For these graphs, the first x-intercept looks like it's at -4, 0, and the other one looks like it's at 2, 0. So I have two locations, 2 points, where my parabola is crossing the x-axis, x-intercepts. And then for my circle, it looks like one of my x-intercepts is occurring at the point -2, 0, and the other one's occurring at the point 2, 0. So again, 2 points where my graph crosses the x-axis. Again, x-intercepts. Right? And so again, very visually, we're looking at points where we cross the x-axis, but we want to do algebra, right? I want to take an equation like 5x plus 2y equals 10, and I want to be able to find where is the x-intercepts. And if I don't have a graph, right, this definition doesn't really do us very well. So how do we find an x-intercept if we have an equation and not a graph? Well, let's go back and look at all our x-intercepts. You'll notice that for x-intercepts, look at the y-coordinate, right? In this line, the y-coordinate is 0. In the parabola, the y-coordinates are both 0. And even in the circle, the y-coordinates are basically 0. So in order to find an x-intercept, algebraically what needs to happen is we have to basically let y equal to 0. So in my working example, if I wanted to find the x-intercept to this graph, I would let y equal to 0. I would plug that in. Now the cool thing about 0 is anything times 0 is 0. So we're left with 5x equals 10. Do a quick division, and we get x equals 2. So this equation, 5x plus 2y equals 10, I'm anticipating its graph crossing the x-axis at 2, 0. So that's how we find an x-intercept. All right. So what about y-intercepts? Well, for a y-intercept, they're very similar to x-intercepts, but rather than crossing the x-axis, they're actually crossing the y-axis. So if we go look at our three graphs, right, this location right here is a y-intercept, and this location right here is a y-intercept, and this guy actually has two of them, right? There's a y-intercept there and a y-intercept down here. So y-intercepts are locations where we are crossing the y-axis. All right, and so again, very visual definition. Works really well when I have that, but what happens when I don't have a graph, right? What happens when I have an equation? Well, for that, what we'll basically do is take a look again at all the values where this is happening. So the y-intercept here is occurring at 0, 2. And the y-intercept over here is occurring at 0, -2. And my two y-intercepts here, one is 0, 2, and the other is 0, -2. And when you go back and you look at all the values, Notice that for all my y-intercepts, the one thing that's constant is that x is equal to 0. So algebraically, that's how we're going to find a y-intercept. So for my working example, if I wanted to find the y-intercept to this equation, I'm going to begin that journey by letting x equal to 0. Putting that in the equation, anything times 0 is 0, so we have 2y equals 10. Do a quick division by 2, and we get y equals 5. And so this graph, whatever this equation looks like graphically, it's crossing the y-axis at 0, 5. All right? And so we can already start to get a really quick graph of this. Let me graph it real quick. So the x-axis we're crossing at 2, 0, and the y-axis we're crossing at 5, 0. And so I can already begin to see what that graph starts to look like. All right, so, and again, I'm going to ask for a third point, but 2 of the points should be pretty easy because x-intercepts, you just let y equal to 0, and it's a little bit less work. And then y-intercepts, you let x equal to 0, and it's a little bit less work. And then we'll work in that third point. But I'll do that in another video because what I was trying to do here is just concentrate on 2 special points. X-intercepts, locations where we cross the x-axis, y has to be 0, or y-intercepts, locations where we're crossing the y-axis, where x has to be 0. We'll use this to our advantage to do some more point plotting and graphing some equations in the next video. I'll talk to you guys then.